We are talking about measures of central tendency and how to do them by hand. So measures of central tendency are a type of univariate statistic, meaning single variable statistic. So measures of central tendency are another way to better understand your sample and to understand your data. So we talked about frequency distributions previously, and a frequency distribution allows you to kind of see the spread of data, whereas a measure of central tendency shows you where the center of the data is. Where are people kind of most likely to congregate, or where are respondents most likely to kind of be? What's the central tendency of the data? So there are 3 different measures of central tendency, and you have to choose the measure of central tendency that is appropriate for your level of measurement. So the first thing you need to do when you are going about doing a measure of central tendency is to determine the level of measurement. Is your variable being measured at the nominal level, the ordinal level, or the interval ratio level? So once you've determined what level of measurement, you can determine which measure of central tendency is appropriate. So as you can see, the mode is appropriate with nominal level variables as well as ordinal level variables and interval ratio. And then the median is appropriate only with ordinal and interval ratio, and the mean can only be done with interval ratio variables. So this is why when we talk about the hierarchy of levels of measurement, we say that interval ratio, or the numerical level of measurement, is the highest level of measurement, because you can do more with a numeric variable than you can with a nominal variable. So you have to determine your level of measurement, and then you can determine which measure of association is, measure of central tendency is appropriate. So let's start with the mode. Now the mode is the category with the highest response rate, or the category that has the highest frequency. And so to determine the mode, you're simply looking for the answer that was given the most often. And so when you're looking at a frequency distribution such as this, you're going to just go to the frequency column and kind of scroll down until you find the category that has the highest number. And so for this example, our category with the highest number is the age 40 through 64, has a frequency of 622, and none of the other categories have a frequency that high. And so our mode is age 40 through 64. And so we'd want to go ahead and put that into a sentence and say the most frequently chosen response is age 40 through 64. So sometimes you'll have a frequency distribution that is what we call multimodal. And so sometimes there are more than one category that have the highest frequency. So if we look at this example here, if we scroll down the frequency column, what you find is that you have 2 categories, agree and disagree, that both have the same frequency, and it's the highest frequency. And so this is what we call multimodal. Now, because there are 2 modes, this would be called bimodal, bi meaning 2. And if it had 3 modes, it would be trimodal. And then beyond trimodal, it would just simply be called multimodal. So sometimes you have more than one mode in your distribution. Okay, so our second measure of central tendency is the median. And the median gives us the midpoint, or the point at which half of the respondents are below and half of the respondents are above. So you're looking for that middle response. And so to start off with, when you have data like this is respondents' age, the first thing you need to do is line them up in order from lowest to highest, from least to most. And that way you can find the center point. So I'm going to start doing that. So I'm going to start with 18. And I'm going to cross them off as I go so that I don't get confused and so that I make sure that I get each of my responses. So then I've got 19 and then 19 again. And it's not a frequency distribution, so I want to write each number even if it happens more than once. And then I have 20 and I have 20 again. and then I have 21, and 22, 23, and 24. And so now what I want to do is I want to go from the edges and I want to count in to the middle point. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 respondents. And so my middle is going to be the 5th respondent. Because for respondent 5, there are 4 below and 4 above. So I'm going to count in 1, 2, 3, 4, 5. And this is going to be my median. So my median here is age 20. And so half of my respondents are below age 20, half of my respondents are above. So if I were to interpret this or put this into words, I would say that the median age is age 20. Or I could say half of the respondents are below age 20 and half of the respondents are age 20 and above. And so that's how you would find the median with some raw data. So what happens if your median or you're looking at a frequency distribution rather than just looking at raw data? How are you going to calculate the median? Well, what you're going to want to look at is you're going to want to look at the cumulative percent column. And so if you remember, the cumulative percent column is a running total. So when you first get to a cumulative percent that goes over 50%, you know that the 50th percentile or that middle point is in that category. So I'm just going to scroll down. The first category that goes above 50%, that's the category that has the median. So in this case, my median corresponds to 55.56%, which is the category of neutral. It's really important that you remember that the category is what the median is and not the percentage. So the median here is neutral, which means that half the respondents are neutral and below and half the respondents are neutral and above. So our last measure of central tendency is the mean, and you're probably pretty familiar with the mean. You probably also think of it as the average score. And so you calculate the mean by adding up all of your responses and dividing by the total number of responses. So we've got some scientific symbols here. So this one here, the X with a bar, indicates mean. And that's what it's always going to indicate. It's always going to stand for mean. So you're going to see this a lot in other equations that we talk about throughout the semester, and it's always going to be the same thing. And then the sigma here is to sum or add up. And so everything that comes after this symbol, you're going to add those together. So when it says to sum X, it means that we're going to add up all of the X's. And X stands for the individual responses. And then N is the total number of responses. And N always stands for the total number of responses. We talked about that when we were talking about creating frequency distributions. And so you're dividing by the total number of responses here. So it's pretty simple to calculate a mean. Let's go ahead and do one now. So here we have our responses to the question of how old are you? And so what we need to do, we don't have to put them in order, we can simply add them up. And so I'm going to just make it easy and put little plus signs in between rather than have to rewrite the whole thing into an equation that basically looks the same. And so if I add all of those up and I have an equals, we're going to have, let's see, add them up real quick, 19, 24, 18, plus 20, plus 23. You're going to end up with 186 as your total. So if we go back to our equation, the mean equals the sum of X over N. And so the sum of X over N is our equation. And so this number, 186, is the sum of X. So if we write 186 and we're dividing that by n, which is the total number of responses, and there are 9 responses. That's going to give us 20.67. Now remember, we're rounding to 2 decimal places. It's actually in my calculator 20.666666, but we go ahead and round that up to 20.67. So if we were to interpret this or write a sentence about this, we would say the average age in this sample is 20.67 years old. And so that's how you calculate a mean using the raw response. So how do you find the mean when you have a frequency distribution? When you have more than just a few responses, you're not going to want to add them all up individually. And so what you can do is you can use the frequency distribution to calculate your mean. And so what we want to do is we want to take the response, that number, and multiply it by the number of times that it occurs, so the frequency, and then we're going to add all of those together and then divide by n. So basically the process of multiplying 18 times 15, age 18 times 15 responses, is basically the equivalent of adding 18 together 15 times. And so that will give us our sum of x. So if I just were to go in here and I'm going to multiply across. I'm going to multiply across this direction. So I'm going to put in my x's for my multiplication. And then I'm going to have an equal sign over here. What I'm going to do is I'm going to have 18 times 15 is going to give me 270. And then I've got 19 times 22, which is 418. And then I've got 20 times 13, which is 260. And then 21 times 22 is 462. And then 22 times 18 is 396. So if I add all of those together, what I'm going to have is the sum of x. So our sum of x is going to be 270 plus 418 plus 260 plus 462 plus 396 is going to give me 1,806. And then my equation for the mean is the sum of x over n. And so we have 1806 divided by, and then we just have to add up our frequencies. And so we have 15 plus 22, 15 plus 22 plus 13 plus 22 plus 18. And that's going to give us 90. And so we're dividing that 1806 by 90, and that's going to give us a mean of 20.07. So our average for this group of responses is 20.07 years. And so that's how we would calculate the mean when using a frequency distribution. So sometimes you will have what are called unusually high or low scores, or what we call outliers. And what we find is that when you have outliers, when you have like one or two individuals in your sample that have really high or really low scores, it's going to skew your distribution. And so the median and the mode are the least affected by high or low scores, by those extreme scores or outliers. It's not going to affect them hardly at all, if it even does. What is affected is the mean. The mean is very much affected by extreme scores. And so when that happens, you have what's called skewness. So let's take a look at skewness. A normal distribution, when everything is normal, when you don't have any outliers, that's when you have a normal distribution. And in a normal distribution, the mean, median, and mode are all the same. And the shape of the distribution is perfectly bell-shaped. So what we have here is a histogram, and in this histogram we've overlaid kind of this curve that kind of lines up with the points. It's kind of a line graph overlaid with a histogram. And what you can see is a perfect bell shape here. What you'll also note is that if I cut this in half, directly down the center where the mean is, and I folded it over, I would have matching sides on both ends of this. And so this is a normal distribution. And this is what all of our statistics that we talk about this semester are going to be based on the assumption that our data look like this. It's all based on properties that we know about the normal distribution. So what happens when it's not normally distributed? Data is not normally distributed when you have some outliers that are going to skew your data. You can end up with something that's positively skewed or something that is negatively skewed. And so you can see here two examples. The first one, number of brothers and sisters, you can see that it's positively skewed. You have a few people up here who have 20 or more siblings. Most of the people in the survey, most of the respondents, have 1 to 2 or 0 to 2 siblings. But there are a few people up here that are pulling that up. And so in this case, the mean is going to be higher than the median. And so this is going to be a positive skew. And so one other thing that you can tell if this is a positive skew, other than looking at the mean and the median, is what's called the tail. And so you can see my line here, I got this tail sticking off to the side. That tail is to the right, and so it's positively skewed. When I look over at my other example here, highest year of school completed, most people have completed 12 or more years of school. So most people in the United States have a high school education. But there are a few people down here who don't. There's a few people down here who have 0, 1, 2, 3 years of education. And what that's doing is it's pulling the mean down. It's making the mean lower than it naturally would be. And so the mean is going to be lower than the median and the mode. And so because of that, we say it's negatively skewed. We can also see that it has a tail off here to the side. So we've got a tail to the left that tells us that it is negatively skewed. So again, to know if something is positively skewed, you've got the mean is higher than the median, and you have a tail to the right. For negatively skewed, you have the mean below the median, and the tail is to the left. All right, that's all we have for measures of central tendency and for skewness and normal distribution.